Hi, Mrs. Matlock. This is Donovan. This is part 2 of the Polynomial Project Makeup or update. This is the obstacle course that I made. And if you were to use like a video game character like Mario or Sonic, you would like jump over here, click this one, jump here, fall down, click this one, jump here, jump over here, jump back over this way, jump up to this one while collecting this stuff. This is function 1 going through the obstacle course in factored form, and it's right here. And to tell what the degree is, it would be 3, using the function, it would be 3 plus 2, that's 5, add 1 here, that's 6, and another 1, that's 7. If you look at the graph, you got a multiplicity of 1, a multiplicity of 3, that's 4, multiplicity of 1, that's 5, and a multiplicity of 2, that is 7. If you look at the roots, you got a positive 1, a negative 2, a positive 2, a negative 1, because those make it equal 0, which is equal to 0. If you look at the graph, it's where the x-intercepts are. So it'll be negative 2, negative 1, positive 1, negative 2. The end behavior for this graph is odd because it goes down on one side and up on the other. So if you use a negative number, you get negative times negative, that's positive. Negative squared is positive, so they're all positive. And negative cubed is a negative, so you get negative times positive, that'd be a negative. However, if you use a positive number, you would get positive times positive, that's positive. Positive squared is positive, and the positive cubed is positive. If you want to make this a degree higher, into a degree of like 8, then you would get positive, positive, that might be a positive, and you get positive squared is a positive, positive to the 4th power is a positive, and all is positive. Then you would get if you use a negative number, it'd be negative, negative, that's positive. Negative squared is positive, and then positive times positive, positive. Negative to the 4th power is also positive, so you get only positives. This is function 2 in factored form going through the obstacle course. If you look at the degree, it is 6 because you have 2 plus 3, that's 5. And then you add another 1, that would be 6. If you look at the graph, and this is multiplicity, so it would be multiplicity of 1, multiplicity of 3, that's 4, and multiplicity of 2, that is 6. The roots for this function are 2, negative 1, and negative 2. You can use that through the function because if you use those numbers, you can make all of these equal 0, which all multiply to each other to equal 0, which is equal to 0. If you look at the graph, it's where the x-intercepts are, so you get negative 2, negative 1, and negative 2. If you're looking at the end behavior of this graph, it is an even end behavior because they both go up in the same direction towards the positive area. Now, if you were to use a really big negative number, it'd be negative, and then negative squared. Positive, so it'd be positive times negative, which is a negative. But a negative cubed is a negative, and negative times negative is a positive. If you were to use a really big positive number, you get positive. Positive cubed is positive, and then positive squared is positive. Positive times positive is a positive. But if you were to compare it to another graph and make it a degree higher to a degree of 7, you would get a negative times a negative to the 4th power, which is positive, and then positive times negative is negative, and then negative squared is a positive, so positive times negative would be negative.